I want to take a quick minute to show you how to determine if a rational expression is undefined. When we ask what makes it undefined, or possibly what the domain can't be, what would be numbers that are not in the domain, the question could be worded several ways, but essentially what we want to know is what is going to make this fraction become undefined, meaning that we're wanting to know what is going to make this this trinomial be equal to 0. Okay, so that's what we're really looking at, is what makes this be 0. And so we want to look at just this denominator. That's the only thing we care about. We do not care about what's on the top for this particular type of question. So if it asks for what makes it undefined, what we really want to do is we want to take that expression and we want to set it equal to 0. And so I'm going to say x squared minus 10x plus 16 equals 0. And really I'm going to say it's not equal to 0, because what we want is for that not to be 0 on the bottom. But we're going to solve it just like we would any other quadratic equation. And so the best way to do that is to do it through factoring. And so we're going to factor this, and we're going to be looking for two numbers that will multiply to give 16, that are also going to add to give 10. And so numbers that multiply to give 16 that add to give 10 will be 8 and 2. Our signs are going to be the same because the sign is positive, and then the biggest number gets the negative. So it's a -8, -2 because the signs are the same. And then we want to take both of those and set them equal to 0, or in this case, not equal to 0. So our two equations are going to look like that. And then in the first equation, if we add 8 to each side, we'll find out that x cannot be 8, and also that x cannot be positive 2. And the reason is, if we were to take this 8 and we were to take it and put it in for x here, well then x minus 8 would be 0, and 0 times something else, doesn't matter what it is, 0 times anything, would be 0. And we don't want it to be 0. And so that's when we say, well, x can't be 8. If x is 2, and we put it in up here, then we would say 2 minus 2, which would be 0, and 0 times something over here would still be 0. And again, we don't want it to be 0. And so because of that, we say that x can't be 2. So here's another example that we can look at. Again, same question. The question is, what makes the rational expression undefined? And so again, what we're really looking at is what is going to make this denominator be 0. And so what we're going to do, again, to find that, is we're going to just simply take that denominator and say that it can't be 0, because that's what we want to know. And so we're going to say x squared minus 5x plus 4 does not need to equal 0. And again, we can factor that. So we're looking for two numbers that multiply to give 4 that will add to give 5, so it'll be 4 and 1. And our signs are the same. Again, we know that based off of this sign. Signs are the same, both going to be negative. And so there's our factored form. And to solve that equation, then we're going to take both of those and set them equal, or set them not equal to 0. So we'll say x minus 4 can't be 0, and x minus 1 can't be 0. And again, if you solve each of those, in that first equation, we'll add 4 and get x is not equal to 4. And in the second equation, we'll add 1, and we'll find out that x doesn't need to be positive 1. And so that's just a couple of examples to show you what we mean when we say we want to find the numbers or the values for which the rational expression is undefined, or numbers that are not in the domain. So just want to give you a quick couple of examples there, and we'll try to follow up with some more videos in the near future.